the session. Okay, 1 second. So cool. Welcome everyone to this amazing workshop about leveraging knowledge graphs for advanced retrieval augmented generation. Many of you might hear knowledge graph for the first time, but LinkedIn is completely based upon knowledge graph. How every connection is connected with each other, how every interest is connected. And if we search anything, and they have been using knowledge graph for a long time, and it is a very efficient way to store information and get in, you can say, knowledge out of the knowledge graphs, because uh, relation databases store data very traditionally, and it takes a lot of time in extracting the data. But knowledge graph is quicker, faster, and that is the future what we see. How we are going moving towards knowledge graph for advanced retrieval augmented generation, which is a very hot topic right now. To talk more about this session, we have a one of our old community members and guest speaker, Isham. And Isham is an AI engineer. He is working at KNI, and this event is in collaboration with KNI. I don't think Liuji has joined right now. Maybe he will join later. Maybe we can have a quick word from him. But this is a collaboration with KNI, this event. And what Ishan does, he focuses on R&D. He is very passionate about what he is doing at the moment. He has completed BE in electrical and electronics and engineering and MBA in finance and operation. He has worked in various sectors and overall 6+ years experience, and works in the field of latest technologies that are coming up. Over to you, Isham. The floor is all yours.
Thank you for the warm welcome. Let me share my screen. My screen is visible, right?
Yes, we can see.
So I will skip the introduction part since it's done already. So I'll be directly starting with the knowledge graph fundamentals. So as we all know about the linked list, which was introduced when in the computer science and data structure and algorithm course. So in linked list, nodes are connected to each other via a pointing arrow. So, and nodes are also holding the data. So similarly, in knowledge graph also, there are that can be, either can be one node or either there can be million nodes. So each of these nodes are connected to each other, and these nodes hold particular information. And how those nodes are connected? By arrowhead. I'll show the example. So this is example of node, James. And this is connected to another node. So this arrowhead is known as the relationship. So that's how the nodes are connected to each other by a relationship. So each nodes can have the nodes and relationship both has labels and properties and labels. So for example, this node is a person. Name is the property and label is James. Similarly for relationship also has property and label. This relationship, the property is has lived in, and the label is Tour Eiffel. So it is the label also for this relationship as well as the node. So this relationship can be one to many. This is an example to one to many relationship, and it can be many to one also. For example, Mona Lisa. It is painted by Da Vinci and it is about La John Good Washington and James likes. So this is one to many relation. And this is many, sorry, this is one to many relationship. And this is many to one relation. And relationships always has a specific direction and a type, which is the property basically. So moving on, Langchain. We all know what Langchain is. It's a Python library. It is in JS as well, so that we use the maximum potential of the large language models. So what makes it special is like there are many built-in functions as well as built-in prompts, which exponentially speeds up the speed for the developers. Therefore, it enables context-aware applications. So it has already many built-in features, for example, the question and answer, then summarization, question and answer of the PDF or text file or any websites. Then it can do it. It has the built-in function for summarization of unstructured data, of course, PDF, text file, and website. And then also we can build within 15 minutes, we can build conversational chatbots as well using Langchain library. And yeah, so these functions are really modular and flexible in structure. So for our use case, we'll be using Neo4j. This module will allow us to connect with the Neo4j database, which is in the cloud. We'll see the Aura DB and Graph QA chain. This will allow us to interact with the Neo4j graph database in natural language, which we'll see in the upcoming slides. So the use case is video games. So why I have chosen video games is personally attached to it. And in the school days, after coming from school, I used to play video games. And not only that, it is also a multi-billion dollar industry. So, and we can uncover many market trends based on the genres, platforms across many regions. And also this data set has 16,000 rows, more than 16,000 rows. So it forms as a very good use case for our study. So not only the basics will be touched, it will allow us to go for intermediate concepts also. Then next. So the features of the data set, this I have got from Kaggle from the dataset dictionary, data dictionary. So the rank is overall sales. So each game is ranked by overall sales. So not only across the particular region like North America, Europe, like overall sales, the game has been ranked. We will see the data set, it will be more clear. Name is the title of the game, platform can be PC, PS4, Xbox, etc. Year, the year which year it is released. Then genre can be action, adventure, or sports. And then publisher can be Nintendo or EA Sports, which releases FIFA. And these are the sales across regions, North America, Europe, Japan, other regions, and the total global sales. And these are in $1 million. Unit is in million. So I assume everyone has set up the Neo4j or DB. So now we will go to the practical side. So I'm using Google Colab so that no one has any technical issues. I need to mount it first so that I can access this drive where my folder is stored.
Isham, can you quickly tell about that installation? If you can just share the link on the chat, like the one that you just told. Maybe some of them have
So,
not installed. Yeah, you can just take everyone who has not installed, just take a
so we
photo of
don't have
this.
to install. We just have to set up document, set up the account. Sorry.
Okay. Can you just
Yeah,
share,
yeah.
put this link on the chat, if
For
possible?
sure, for sure.
Yeah,
I will
that will
put it.
help. It will just take
Yes.
couple of minutes. It is just, you don't need to install. You just need to. It's like a. I think it's just like an email, right? Simple things you need to,
Yes, yes,
like
yes.
any
I will share it
any
in
open AI
the.
key or something.
Yep.
Yeah. Thank you. You have put it on the Zoom chat. Uh,
I've shared in the WhatsApp groups.
okay, and then directly on the WhatsApp. Okay, cool. I'll put it on the. Yeah, I put it here also in the chat. Okay, sorry, carry on. Yeah. So, uh, okay, Sabah is saying I'm not interested in WhatsApp group. Okay, we have put the link here. You can take the link from here. You can just it will just take couple of minutes. Get started for free, and this is just like a DB accessing a database. You will get. So, what is the output from this, Isham? We get a token or something.
So we'll get, once we spin up an instance, it will ask us to download a text file. And there it will give us the environment variables, which we can use it.
Cool. Yeah.
So I will move on to the code part. I need to navigate to the directory where all my code is. Let's confirm if it's already cd'd or not. Change directory basically. Now I'll install the dependencies. Here again, there will be like a minute or so. So usually in the local PC, we are using .env files. But for Google Colab, we are using this attribute user from google.colab user data. So how we are storing the env variables is we can see the key sign, we click it, and here all I have stored the environment variables here. And in order to access this, we are using user data attribute. I'll run this. So now it is not asking me, but when I run for first time, it asks me that access is not granted to this notebook. So it will prompt me. Then we'll need to assign as A and V variables os.environ. So this will allow us to assign the environment variables to it here. So loading the data set. So it has 16,598 rows, which is good enough for the practical workshop. And this is our data set, first 5 rows. You can see the rank. This is based on the overall sales across all the regions. This is the name of the game platform. It can be PC or PlayStation 2 or yeah. And this is the year in which the game was released. This is the genre. It can be sports, it can be action, it can be RPG. And then publisher, it can be Nintendo. This was already discussed. So now we can see it in the form of table. It is more clear now to us. And these are the last 5 rows of the data set. So this is done to see if the data set includes the feature which can act as unique unique ID or not. So we can see that it might be a good idea to check if rank is if we can use rank as unique ID or not. So this matches the rank. The number of the rank is the unique rank is same as the number of rows. So this can be used as unique integer. So now this will allow us to connect to the Neo4j Aura. So this is connected successfully. Otherwise, it would have thrown an error if it didn't connect properly. Now, this line of code is very important. So this allows to convert the CSV file. It allows to convert the CSV file to Neo4j graph. We'll see how it does. So I'll run the cell. This will take a minute or so. So until then, I'll explain what is going on. So merge, for example. So this is, so there is the game feature. So we are naming it as game instead of name. So this will be our main node. And then we are linking to this rank. And then this rank, as it has unique ID, as it is acting as unique ID basically. And now we'll be setting the properties of the game. So here name g.name. So this allows us to create a node, name game. And here we are setting the properties of that node, game. So g.name, row.name. So we are connecting row.name. For example, Wii Sports, we are connecting here. And then platform. Platform here, for example, this is Wii. So here it will be Wii. And here and so on. So we are creating properties for this node game. And similarly, we'll create other nodes as well. So this will allow us to create a platform node. And this statement will allow to form relationship, the game related to the platform. Similarly, publisher, we created publisher node also. And then we created genre node also. So out of all the features, we have selected only four nodes we have selected as our features. Rest all can be properties of those nodes and relation. So now it is showing empty list. So we can confirm whether the CSV is converted or not. That's why I've opened another window here. So this statement will allow me to return all the nodes that is available in the Neo4j database. So here you go. So the limitation is 1000 nodes. So it is displaying only 1000 nodes, not 17,000 nodes. So these are the maximum possible nodes that can be visualized. And this also confirms that CSV to Neo4j conversion is successful. We can also verify via the code. So it is verified via the code also. So node properties, game. So we created the game node, then platform, publisher, genre, sorry, and then relationship properties. How game is related to the platform based on
Uh,
released on which platform it is.
Isham,
And
can I
then
ask one
yeah,
question? One.
sure,
So
sure.
if we have the premium version of Neo 4G, we can see more. We can see the result preview more, or is it there's a limitation uh, as well for that?
Think there is limitation because in Neo4j desktop we are using, even that is like 1000 nodes. That is the limitation actually.
Okay. Even if we have a premium also, we can only see 1,000 in the preview.
Actually, I'm not sure about it.
Okay.
Yeah, yeah.
Okay, cool. And because right now what I understand that total nodes are around 17,000,
Yes.
but they have only selected 1,000 and
Only
randomly they have
1000 it
selected.
is
It is
showing due
not,
to
yeah, it
memory
is,
limitations.
yeah, but it is not showing the center node or the main node or nothing like that. It is just randomly showing 1,000 right now, and later on, but we have
Actually, there
everything,
is
all
no
the,
central node. All nodes, like here we have,
okay,
yeah, based on our settings, it is doing it basically.
okay.
We
So
can
there is
set a
not,
center node also. We can
yeah,
set,
because like it happens, right? Like one, something like you showed Mona Lisa is connected to lot of
yes,
things. So here also,
exactly.
I'm sure there are some nodes that are connected to many multiple nodes accordingly,
Yes,
and
see,
some are,
for example, Atari game.
yeah,
Here it is many to one,
yes.
like this. Here
Yes,
also
yes.
same
Here it is a lot, huh?
Sony Computer Entertainment.
Yeah,
Here also many to one, many is forming one.
yeah. It's interesting to
And
see the
why
data
it
at this.
is, hmm?
Yeah, it is interesting to see data like this in a different
Yes, it is for sure.
way.
And also why they have limited is because the PC slows down. I have like real experience. When I try to visualize, even with 32 GB RAM, it slows down. So it consumes a lot of RAM also.
Okay,
So that's
cool.
why they
Thank you,
have put
thank
this
you.
limitation.
Yeah, yeah. Thank you for.
So now we'll be moving to the queries. So why we are doing this queries first of all, like why we are not jumping directly to the natural language to the results. Why not? So this will allow us to gain some basic knowledge about the Cypher query, which is analogous to SQL. So this will allow us to do more better debugging. For example, if the LLM generates from natural language to this Cypher query, and that Cypher query is working well. So if we don't have knowledge about this, we might think that that Cypher query is correct. We will not know if it is wrong or not. So understanding this will allow us to identify whether the Cypher query that is generated by the LLM is correct or not. And then accordingly, we can change the prompts and modify to give us the right results. So I'll run all the nodes. So this is the most simplest Cypher query that will allow us to return the number of nodes that is existing in the Neo4j database. So total number of nodes are 17,220. But to improve its readability, we can change it to number of nodes instead of n, count n. So we can do that as well. So this is known as aliasing. So here it returned as the total number of nodes. Then we can count how many nodes are, how many game nodes we have. So number of games we have is 6,598, which is same as the number of rows. So this is same. Then we can see the number of publishers, how many publishers are there? 579 publishers. Let's run this. So we can confirm which publishers is there or no. For example, Nintendo, which everyone knows how great games they make. So I've chosen Nintendo example, whether it exists or not in the database. So it exists. And then now we can see the global sales of this game, GTA, San Andreas. All of us know which game this is also. It's to play back a lot back in 2000s. So these are the global sales in millions basically. So we must be wondering why it is repeating without, we'll see in the next example why it is like this. So what we can do is like, can check here, this is global sales. What features we have here? We have the genre, we have the year also, and we have the platform. So we can check for all platform, year, genre. This will be platform. Let's see why we have four of this like this instead of one. Okay, so now we can see they're released in different years. That's why we have like this. So in 2004, they made this much amount of sales. 2005, this much. So now we are getting the complete picture as to why this repeated. So we have returned more than two. Instead of one, we can return multiple properties. Now we can do query matching. This is very similar to the SQL where we are doing conditional matching. So we want all the 90s games to return to us. You see, and this is how all the games are. And this is the list of 90s games from this dataset. We can run it here as well, directly in the Cypher shell. And there you go. It returns in the form of tables. So this is very similar to SQL. So that will also allow us to speed up learning this Cypher query very fast. Pattern matching with multiple nodes. So this is one relationship which we formed in the beginning, belongs to which genre. So basically what we are doing is here. So which game is belong to which genre? So genre can be action or it can be RPG, role playing, racing. And then we return just the 10 just 10 games were returned. So this is the pattern matching with multiple nodes. There can be more nodes also. So here in this example, what we are doing is, so here there is Super Mario Brothers, which is published by Nintendo. And then it will not return as Nintendo, but the other games, which is published by same. So other games will be returned. So here we don't know which publisher is, but it will return the other games with the name and its global sales. And here is the results. Now we can also delete the data from the graph. So I've selected an example, which is, for example, this Nintendo Dogs. This is not a popular game, so we don't want it in the database. So this is before. We are verifying whether it exists or not in the database. So it does exist, and now we don't want it. So for deleting data, we need to delete the relationship first. Here also it's there. And it is published by Nintendo. So we'll delete this. So now relationship has been deleted. We can verify it from here also, like after, by running the same statement. So now it is giving an empty list. Therefore, it indicates that it is deleted. But the node is still existing. We can check it here. The node is still existing. So why we cannot directly is it just gives an error. So we need to delete the relationship first, and then only we can delete the node. So this is the statement to delete the node in Cypher query. To delete a node, yes. So empty list is returned means it has been deleted, and now we can confirm the total number of nodes. So we can see a drop. We have deleted a node successfully now. Initially it was 7,220. Now it is 7,219. Let's move to the slide now. So why we have selected knowledge graph instead of SQL? So there are certain advantages are there over SQL as well as the traditional reg. So here there is schema flexibility. So without making changes to this data structure, we can add one node or many nodes without making changes to this data structure. So we'll see an example of this also in the notebook too. Handling complex relationship. We'll see how nicely it also handles complex relationship when we see the example for natural language query, when it gets converted to Cypher query, and then we retrieve the results. And then query simplicity and readability. So it is more simpler to read the Cypher query compared to SQL. And also it is nicer syntactically also, and also in terms of efficiency and speed also. Because when we perform joins across multiple tables, it really slows down a lot. But when using Cypher query, It is much faster because all the nodes are interlinked to each other. It will just be a traversal instead of going through complex procedures. So syntactically as well as speed and performance, Cypher query is much superior to SQL. We'll see the example for this both, and this example we'll see in the third notebook. And explainability and traceability. So we will also see like we can do the traceability by copying and pasting the generated Cypher query. This will be also covered in the third notebook. Now we'll see. Opening the notebook. Same first procedures. So let all these processes go. I will explain, I will show the how syntactically nicer it is compared to SQL. So this is an example, same example. So this is in Cypher language, and this is in SQL language. So we can see that how simpler it is to write in Cypher query instead of SQL. These are doing the same operations, but we can see the number of lines of code also has been reduced, and also the number of what you can say the commands basically. So that also has been reduced. So syntactically we can see this has advantage over SQL. So, but I don't have example for this like practically. But yes, when we perform a lot of joins, there will be it will slow down. The results will it will be retrieved at much slower rate. This is connected. We'll refresh again. See, okay, we are connected successfully. Now, this is an example of schema flexibility. So this game Hades does not exist in this database. Why? Because this data set is it has the records from the 90s, from 1984, yeah, from 1980 or 1990 till 2016. But Hades game was first released on 2020. So that's why it is not there in this data set. So we'll verify whether it is there or no. Still, we can verify game node, and within game node there is Hades or not. So it is not there. It is returning empty cell, empty list. So now we'll create a new node, Hades, by just using create command, and that's it. It will create us a new node. And after we can also verify it via the Cypher shell. This is the Cypher shell. And it is created successfully. But it is not linked to each other. That's why we don't have any of the properties. So we need to set that. So before giving it properties, we need to formulate relationship. So Hades will come under genre role playing, yes. So we are establishing relationship via this command will allow us to do that. Now we click and there you go. So relationship has been established successfully. And now we will set the properties, release year, genre, and developer. Instead of developer, this can be publisher, much better. And we run this cell, we can refresh. And we have successfully set the properties also of the new node. And it is under games. So without making any changes to the existing database, we have simply added a new node, just like that. So this exhibits how flexible it is in terms of the schema. And this example I've gone through already. We can check whether it gets executed or no. Yes, it is returning us the total sales for each of the genre. Now we'll move to the third notebook. I think everyone is waiting for it since here we will be using Langchain.
Now we have the generative AI part, the most
Yes,
interesting part.
most interesting part.
But it takes 40 minutes, it took almost to prepare the data, right? That is the most important thing.
Yes,
And
yes, yes.
applying generative
Now
AI
it
is
will
the
take
last
lesser
part.
time.
Yeah.
Just run this cells quickly. Important. So there is a bonus tool I want to introduce, the Langsmith. So why we will be using Langsmith is it will allow us to debug it more. It will be acting as a debugging tool basically. So we'll know like if there is anything wrong in prompts, instead of going through the libraries, it is not a good practice. So Langsmith will allow us to see the prompts, the internal prompt templates, basically. Internal prompt templates as well as the external also, if we modify, if we pass in to the method, to the method which is provided to us by Langchain. So we'll be seeing how Langsmith will be used for this use case also. So now we'll be initializing the Neo4j graph. So this comprises of two parts actually. So the first LLM, there will be two LLMs involved. First LLM will be the Cypher LLM that converts this natural language to the Cypher query language. So once the Cypher query language is generated, it will be executed behind the scenes It will fetch the results from the Neo4j database, but it is in form of list, which is not readable. It is only good for us developers. So it should be also understood by non-technicals. So for that, QA LLM comes into play. For this use case, we are using GPT-4 Turbo, but we can change this. 3.5 didn't give me good results actually. So that's why I haven't used 3.5. I've tried with 3.5 as well. And also, if there is concern of privacy, we can use Olama. We can install Olama in our PCs, provided that we have GPUs. That is also one thing. And I've tested, okay, we'll come to in the last slide, I will discuss about it more. So this is the simplest example, which games have same publisher in year 2003.
Uh, I had one question.
Yeah, sure.
So now, right now you are using uh, Langchain and you're using OpenAI GPT. How you are
Yes.
ensuring that this question is going to get answered only from the knowledge graph and not from the LLM?
So how I'm doing, okay, I will open the Langsmith. That's why,
Because sometimes the LLM, as you understand, right, they will give you an answer,
yeah,
but
I,
it
I
will
will show
not.
that. I will show that.
Uh,
Langsmith, 4 projects, AI workshop.
oh, you're no, this you're used to monitoring and evaluating this project.
Yes, yes. So this KNI workshop, let me show. See, here are the API keys for Langsmith. Once after registering,
Okay.
so we need to set certain environment variables.
For every project, it will be separate for Langsmith.
For, for every project, it will be separate, provided that we provide the project name.
Okay.
Here are the environment variables.
Mm.
So Langsmith API key we get after registering, which will be fixed. And Langchain project, it will be created on the fly actually.
Hmm.
Once we execute this, it will be created on the fly. If this is set to true, then all the executions will be reflecting here. And now we'll see like how we'll ensure it is not from LLM. So here is the prompt template. Generate Cypher query, Cypher statement to query graph database. Do not use any other types that are not provided. So it's all prompt engineering actually. So that will
Yeah.
allow us not to answer from the LLM. So how it is going first is, so it enters the graph QA chain. This is our question.
Hmm.
This is our final output. So this part, Cypher query is generated. Cypher query generation is done.
And this query
And
is
then,
now this query now runs on the knowledge graph,
yes,
and
it will be executed behind the scenes.
then it gets then it gets some JSON output, and then
Yes, exactly.
it makes into a conversational style text using the
Yes,
LLM,
exactly,
and
exactly.
then puts it
So
there.
that will be passed to the LLM chain. Here is the
Great.
LLM chain. And now it is going to, this is the QA LLM prompt. You are an assistant that helps to form nice human readable answers. This. You must never doubt or try to use. So here it is mentioned.
Yeah.
Make the answer sound as responsible. Do not mention that you based. Okay.
Mhm.
And here an example is also given. So this is a one shot learning, you can say. So here we are passing the information. These are the results, the JSON result, as you said. And this is the question, and then it will give us the answer in human readable format. So this was a simple example. We'll see more complex examples. Find pair of games published by same publisher in year 2003 and then combine. So if we do this manually, this will take us a lot of time, maybe an hour or so. Even if we know the syntax for Cypher query. But using LLMs, it can be done on fly. How fast it is generated.
Have you done any QC to check whether the answers that are coming are actually correct? Uh,
QC, yes. So there was an like why we have used knowledge graph, explainability and traceability. So now we'll be coming to this part and also handling complex relationship. So this both advantages are covered as we can see. So this is a very complex query, but it got generated in no time. So now let's verify whether we can run it even on the window, even on the Cypher shell. I mean, I'm struggling with dragging the window. And this works. Okay, it didn't return us the sales. I'm not sure why. It should have returned us the sales also. Okay, we'll run it again. Yes, now it is showing total results. So we can see like at one shot it didn't give us the correct results. But after running second time, we are getting the right result. So I have a solution for that also, which I'll be discussing in the last slide. We'll again verify. And there you go. The total global sales for the games, pair of games basically. So at first shot it didn't work, but second shot it worked. And here is a list. Super Mario and Mario Kart, Pokemon Go and Mario Kart, and etc. etc. Now we'll move on to the third example. Find most successful publisher in 2008 in terms of global sales and list their top three games. Okay, we'll run this also. This is also one of the very complex query. Usually this doesn't get correct in first attempt. It takes a lot of attempts, then it gives us the right results. But here it gives us in first try itself. Nintendo. And top three games. This is this. Okay, it is giving us the right results. Then we move on to this example, determine the average sale of games by publishers who released at least two games in 2001 and compare the averages. See how this runs. So this is the final result. Nintendo leads with average global sales of this much. And it is making the following comparison of at least two games. Now we'll be running the last example, identify publishers who released games in both 2001 and 2 and compare their global sales for each year. And this is the final results. And here is the comparison. Clear cut. So that concludes the demo, and we'll see the future work. As we know, the data set is very old. Some recommendation for future works. So last updated, it was on 2016. But we have very advanced tools nowadays for web scraping. So from the same VGX chart G, we can scrape off the data set from 2016 till 2024. So there has been tremendous sale, of course, in the last 8 years. It's a big gap. So in last 8 years, there must be a lot of sales that happened. Enhance the data set with new features. So there was one feature, important feature that was missing was the number of players that played. How many number of players across genre and across the publishers across for each of the games. So the number of players was missing. So we can include that also, and then we can again convert it into Neo4j and continue the experiments and ask more complicated questions to it. And we can not only try this games dataset, we can try various other datasets also. For example, books, and then there can be research-based datasets also. We can try on various use cases, not only sticking for the game. And then now comes the other models. So earlier, like even a month back, 1.5 months back, this models didn't exist. DeepSeek Coder V2, Codestral, Cloud 3.5, Sonnet. These models have performed very well in generating the code. I have used Codestral myself, and it is performing on par with GPT-4 in coding. Though for QA LLM, it doesn't give good results. That's why I haven't used. But for code generation, it is doing extremely well. And DeepSeek Coder, I've seen a lot of LinkedIn posts. They claim that it is outperforming GPT-4 also in terms of coding. So I would request everyone to try using these models, other models. And also there is privacy issues, as I can see from the chats. So that can be easily mitigated also. Here we are using chat OpenAI. We can use chat Olama instead. So we need to set up Olama first, following the instructions, very simple instructions given in their site. And then we can use chat Olama module, same as chat OpenAI, and then we can change the model name. That's it. Very simple. And Olama provides DeepSeek coder also. We can use. So DeepSeek coder is available. So they have quantized these models, but the performance is, there hasn't been, like significant performance, like in terms of the quality of the results. It is giving good quality results as well, even after quantization. So I've used it personally, not DeepSeek Coder, but Codestrel. This one I have used. Yes. This is also lightweighted, 22 billion parameters. So for this, we need like 24 GB, either can be run on RTX 4090 or 3090. And for QA LLM, we can try out using Llama. So for Cypher query, we can use the code models we have discussed. And for QA LLM, we can use, Llama 3B also, we can try. It does really good job for its size. So we can try it out. If it doesn't work, we can try with different models. Ensure consistency in data conversion. So I had a plan to show unstructured data, like in the form of text, to get converted into Neo4j graph. But I haven't covered. Why? Because it doesn't, the data, the graphs which we can see here, for example. So this we can see the nodes, like we'll get consistent result. But when we are converting text to Neo4j, every time I'm running the code, it is giving me different database structure. The whole database structure is getting changed. So that's why I haven't covered. But I believe we can mitigate this also
Yeah,
by doing some sort of
there
mapping
is
in the
an
prompts.
extra layer that we has to be done before
Yes.
we put an unstructured data to this. It's like a normal, everything is like normal data science, right? You need to use
Yes.
NLP techniques, create unstructured data to structure. That LLMs will maybe help you, but it will not be accurate. You need to use your own traditional
We need
coding
to
NLP
use our
technique.
own. But
Yeah,
they are providing the Langchain. They are providing LLM graph transformer. So according to their module, we shouldn't be doing anything. But still, we need to do some extra steps. And also, I will go back to the Langsmith. Here we have given one-shot example. But this is not related to game at all, the example that they provided from Langchain. So this, we can change. We can provide our own custom prompt and we can change the question. We can either add one question or multiple questions. That will allow us to get more better results also. So this is also one of the suggestion. And in the documentation, there is dynamic few shot prompting. I would like everyone to check on that as well. So that is also one of the strategies to get us the best result in one shot, in one try. And we have seen that once we were not getting correct result for this example. In the first time, we didn't get the right result. We didn't get the global sales. So this can be also fixed. Like now we are using chain. So from chain, we can shift to agents. So that agent will take in and verify whether, it is right or wrong. So it will identify the sales weren't present. So automatically, again, it will generate Cypher query as per the wrong, as per the results. And then it will automatically rectify and give us the final Cypher query. But again, there will be a cost issue. So that also we need to take care of. But we'll get better results if we include agents. So yeah, that's about it. So we have covered the basics of, not only basics, we can say intermediate level concepts of Neo4j, and we have also seen how we can improve it. We are getting decent results, but we can improve further in terms of prompting, prompt engineering, also the models, like for, as this is very costly, we can use the local models. So strategies are covered to improvise the system, and whatever is required to get started with Neo4j is covered. So yeah.
Thanks a lot. I know we have short of out of time, but it was very informative. I know this is just a introduction of how you can start using knowledge graph. And I think before you go to generative AI and LLM part, you need to learn about knowledge graph, and it is a learning curve. It is very much
Yes.
different from relation RDBMS, relation database. It is a new concept. So don't directly jump into LLMs. What we require is we require to learn about knowledge graphs, how the data is structured, how it is, how what are nodes, how to create. You may not, at least you may need to understand Cypher, how it is being done, and then dig deeper into the LLM part that is there. But it is a good start to do this, replicate this workshop. Git link. I think we will share all the code location and everything. I don't think it is there on Git right now, Isha.
It's in the folders actually, which I
Yeah,
shared
we will
in the.
share the drive location and everything,
Yep.
PDF and everything. I think yeah. So you can use that, Avril, and we will. I have saved the chat. Most of the questions were regarding privacy. There was one question. Maybe we can take it offline, or you want to take it now from Osama.
Now I'll take, no problem.
He asked about healthcare domain. The same question about
Yes,
data
healthcare
privacy.
domain, we can use it in healthcare domain also.
Yeah.
Right now we are using for RN, like research databases basically. So it is very similar to healthcare domain also. So we can use it for sure.
Yeah. So when people are messaging about Git link, there is no Git link. We will share the drive link
Drive link,
after.
yes.
Yeah, we will share all the required the documents that you can replicate the code. And before we close, any closing comments, any message that you want to give for the next steps? And for me, I told about
So I would
use
like
next.
everyone to,
Yeah,
practice again
yeah.
whatever we have went through. And instead of, using, like, let everyone run using the same data set. But I would also recommend to use different data set which is available on Kaggle and UCI UCI website also. There are many data sets. So we can not only stick to Kaggle, we can use other data set, like other website data sets also. And then it would be interesting to see how we can form relations, like how we have done it manually. So I'd like to request everyone
Yeah.
to
Share your knowledge in the
automate this
WhatsApp.
process.
Yeah. Yeah. Share the knowledge in the WhatsApp,
Yeah.
and you can take. So Sabha is asking, actually, I'm a beginner in data science. Do you have meetups like from the beginning? So there are different workshops that we keep doing. Today was a little bit intermediate level workshop, but we keep doing a lot of basic level workshops also, like for beginners as well. So I will share you. So you be part of the community. You'll be getting updates accordingly. This was a little bit advanced. Yeah, there was prerequisites. You need to know few things, but we do a lot of basic workshops also, that is there. So cool, then thank you everyone for joining, and spending your Sunday afternoon with us, and we will share the recording and all those the documents, the PDF that was used to all of us by tomorrow. Have a great day, everyone. Bye
Thank you,
bye.
everyone. Take care. Bye bye.
Let me take one screenshot. So